you need to take a look at either practice test 1 again, since you have an extra copy, or practice test 3, if you can work along with the video. Right now, we are going to do 2. Practice test 2.
Is it Prequest?
Prequest 2, yep. Prequest number 2, which is attached to number 1 that we did yesterday. Or the day before, whatever day that was, we did that. Alright, so do you remember that kind of hint I gave you when you sit down to take this quest in terms of the order? John, I'd ask you now to take the hood off. I'm going to ask you one more time. Take your hood off. Okay, I'm sorry, you didn't hear me. I said it. Now, when we sit down to take this quest thing, anybody remember the hint I gave you? Do problem number 1 and 4 together, because 1 and 4, look at the first 3 words, convert to rectangular. So what does that mean if we're going to convert to rectangular? That means we want to find an X and a Y. So somehow we have to come up from this given, we have to come up with an X and a Y. When we come up with an X and a Y, there are 2 ways that we can write our answer. We can write it as an ordered pair, X comma Y, or we can write it as X plus YI. Okay? Now, I'm getting my calculator ready because I know what's happening, what's coming up. How do I find X and Y?
X equals 4 cosine 201, or 4, X equals 4 cosine 201, Y equals 4 sine.
Exactly. So Jake remembers these things we absolutely have to remember. X equals our cosine, Y equals our sine. Right? Well, ours should be theta, not 201. It's not always 201. X equals our cosine theta, Y equals our sine theta. So for us, that's 4 cosine 201, so I can just type that in. And it's negative 3.73. And for sine 201, negative 1.43. All right, Robert?
Yep. Do you happen to have another one of those packets?
Probably not. I handed these out a long, long time ago, but you can take a picture of somebody's. Why don't you just do that and put it in Notability or whatever you kids do. Or just write the problems down as we go. I'll write them all down. Okay. I do have it. When I get an extra copy of the first one, because I handed that out yesterday. Oh no. I have to get you an extra copy of the first one. Okay, so now I have to decide, now that I figured out what X and Y are, I have to figure out how I'm going to write my answer. So you have the others, Robert. I'm just going to look at them.
All right, thank you.
So which is it? Which way am I going to write my answer? I now have my X and my Y. Which way am I going to write my answer? In a coordinate pair. And why am I writing my answer as X, comma, Y? Well, yeah, the question said find the coordinates, but another reason is the problem is written as coordinates, and your answer has to match your problem. So it does. Now, when I go down to number 4, the first 3 words are the same. Convert to rectangular. That means I need X and Y. And I'm going to find X and Y the same way I always find X and Y, which is our cosine theta and our sine theta, right? So, what is my number this time is 6 CIS 12. So what's R? 6. Theta is 12. So X equals 6 cosine 12 and Y equals 6 sine 12. Then I get out my trusty calculator. 6 cosine 12 6 sine 12. There we go. Now I decide how I write my answer. My choices are right there. Anytime you have X and Y, this is your choice. Which way are you gonna write it this time? Just like this. Notice, gang, first of all, is the problem an ordered pair? No. So you would never answer as an ordered pair. Secondly, there's an I in the problem. CIS, cosine, I sine. So I need an I in my answer. So 5.87 plus 1.25 I. I always hook the I to the Y part, right? Always X plus YI. Our problems 1 and 4, very, very similar.
Yeah.
The only difference with 1 and 4 is how you actually write your answer, right? How you get your answer is exactly the same, but how you write it is different. Okay, now 2 and 3. Notice they say convert to polar. Wait a second. When it was convert to rectangular, that meant I needed to find X and Y. If it says convert to polar, I need to find R and theta, right? This is polar, R and theta. Okay. The number, or the point I'm starting with is -5, 2. How do I find an R and a theta? Yes, Kartik is back there saying this. He says, Miss Ford, draw a picture. So I'm going to plot the point, -5, 2. Using the same butterfly bow tie that I've used since the beginning of this class, right? -5, 2. This will be my R, always. This is my R. And how will I find my R? Pythagorean theorem. It's like magnitude. We square, and take the square root. So that's going to be the square root of 29. 25 plus 4. Now, this angle right here, I have to figure it out. Theta, the theta I'm looking for is actually going to be the pink one. But I need to figure out that inside one first. And how do I always find a missing angle? Second tangent. So this one's going to be second tangent 2/5. Remember, it's always opposite over adjacent. So it's going to be 2/5. So second tangent 2/5. I got 21.8. Theta will never be the number on your calculator unless you happen to be in quadrant 1. Since I'm not in quadrant 1, I have to figure out the pink angle. And Jake says I'm going to subtract 21.8 from 180. And I'll get what?
158.
Now, I found my R and my theta. Just like with the rectangulars, there's 2 ways to write your answer. Your answer is either going to be written R comma theta or R CIS theta. Well, again, like David said earlier, if you're reading the problem, it says convert to polar coordinates. So that's going to be an ordered pair. The original problem was an ordered pair. So your answer will be root 29, comma, 158.2. That is the final answer to the problem. When you find polar anything, it's R and theta. You have to find R and theta. So the next one says, convert to polar. Now another word for polar is trigonometric, so you got to be ready for that word too. But when we convert to polar, we know that means we have to find an R and a theta. And the number this time is -3 plus I. So we draw a picture, left -3 and up 1, remember it's x plus yi. So x is -3, y is 1. You're finding r and theta. Here's r. Well, what is it?
It's, R is the
Pythagorean
Pythagorean theorem.
theorem. So what will that be this time? Square root of 10. Now, just like the last, this is exactly like the last one. Here's theta, right? So I gotta find this inside angle first, and how will I find that? Second tangent, 1/3. So second tangent, I got 18.43. That is not theta.
So 180 minus.
It has to be 180 minus that. And it's 161.57. So now I have found my r and my theta. But to get full credit for the problem, I need to answer it in the right way. So is it going to be the ordered pair, or is it going to be the CIS notation? CIS. Problem has an I, answer's going to have an I. So root 10 CIS 161.57. Okay? We don't need to hold hands. I mean, I'm all about love and happiness, but not in that class, okay? All right. Now, next page. Try to remember, and I know it's a long way away, but as you do your review work, hopefully over break, looking at this a couple of times, try to remember 1 and 4 are exactly the same math, 2 and 3 are the same. All right. Now, number 5, this is the one, remember, I'm shaming you into getting this right, because I said if you miss this one, all hope is lost. There's no work, 0 work, you just write the answer. What does x always equal? Not cosine, r cosine. So 3 r cosine theta. X is r cosine theta, period. So 3 r cosine theta. What's y? R sine theta. Put it in the answer blank, check it off your list, move on to the next problem. All right, who remembers this one from yesterday? Garrett? Well, that's going to happen eventually, but we're not ready for that yet. What? Yeah, so, and you don't need to do this, but that's kind of a reference thing for you to look at. If you build your butterfly bow tie, this is X, this is Y, that's always R, right? And there's your theta. So you need to be able to substitute in for whatever the function is in the problem. So whether it's sine, cosine, tangent, secant, whatever it is, you need to be able to replace it. So what's cosine? X over R. Cosine, remember, is adjacent over hypotenuse. Now, what do you do once you get that function replaced with a fraction? We get rid of our denominator. In this case, it's an R, but keep in mind it won't necessarily always be an R. It depends what the function is, right? So you get rid of whatever you got. So R squared equals 2x. Then, Derek, now we're ready to replace R squared with x squared plus y squared. And before you say anything, pay attention. This is a right triangle. Doesn't x squared plus y squared equal r squared? Yeah. So that's what we did. Now we're done. So there's our answer. Janae?
On the homework, it was one where like r equals like 2 times r over like y. Like how would you do that? Like how would the answer be?
Like this?
Yeah.
Okay, multiply both sides by y. You multiply by whatever the denominator is. Then in this case, you got an r on both sides, so you just divide it off. So you'd have y equals 2. All right, now we've got these ones where we are adding and subtract, or not, where we're multiplying and dividing. There is some addition and subtraction involved, but we are actually doing a multiplication and a division problem. So we have 10 CIS 60, and we have 5 CIS 70, and we're going to multiply these guys, and we're going to divide these guys, okay? So again, these are super simple if you can remember the strategies. Do you remember what you do? What do you do in a multiplication problem? You multiply the r's. Remember, this notation is r CIS theta. So we multiply the r values, so that's 50. And then what do we do with the theta values? Add them, so that would be 130. Now, we had problems where when we did the addition, we got a number that was too big, so you subtract 360. This one's fine. That's the answer. That's the answer to the first part of it. Now, what do we do when we divide? We divide these, so that would be 2. And then we subtract these. Now, this is bad, because when I subtract those, I get negative 10. You're not allowed to have a negative answer. It's too small. It has to be 0 to 360. So when you get an answer that's too small, you're going to add 360 to it. So the final answer would be that. Right? Now, who remembers how to do this? This is like a multi-step problem, but it's easy. We practice quite a few of them. Who remembers what we do? Well, and kind of, if you look at the directions there, it says answer in polar form, so it kind of clues you in. We need to change this to polar, which means we need to find an r and a theta. So we'll draw a picture of it. This one's over 2 down 2. Right? So I need my r. What would my r be? Square root of 8 or 2 root 2, right? Now, you might find in this problem it's actually easier to leave it as the square root of 8, but it's okay. You're going to have a calculator, so it really doesn't matter. And this is not the answer. We're not anywhere near the answer yet. What about theta? Well, watch it. This is going to be theta, right? That's theta. But hopefully we've done enough of these that you can tell with these two both being 2's that angle is a 45. If you can't tell that, you're going to have a calculator and you're going to second tangent 2 over 2, right?
Yeah.
And that's going to give you 45. What's theta? Theta is not 45. It's 315. Why is it 315? Because it's not quite all the way around, right? All the way around would be 360, but it's 45 less than that. So it's 360 minus 45. Okay, so 2 root 2, CIS 315, raised to the 6th power. Keep in mind, this is the problem. We're raising it to the 6th power. Okay, so 2 root 2 to the 6th power. Are you listening to Jake? Because he knows what he's talking about. He says, we want to multiply this times itself 6 times. Then we want to add 315 6 times. And rather than say 315 plus 315 plus 315, we'll just do 315 times 6. Now, if you're going to put this into your calculator, these parentheses are absolutely necessary. If you don't put in those parentheses, you will not get the right answer. And the right answer is 512. You should get 512.
Answer is 90 for that one.
It's 1890 to start with, though, right?
Yeah.
Yeah. So here's my first stage of my answer. Everything's hunky-dory, except 1,890 is just a little bit too big.
18.
So I'm going to subtract 360s
5 times.
as many times as I need to. Derek says 5 times. I need to pull it out. So my final answer will be 512 CIS 90. Is that right? Done. Okay. Now we got our graphing to do.
Problem like that, how many points would that probably be worth if you get all of it right? That's like a ton of work.
Quit whining, Pop. That's not a ton of work.
No, I'm just saying.
It's
like-
more than
like
some
a
of the
lot.
others,
Yeah,
for
that's what I
sure.
heard.
So it's probably worth double what the other ones are.
Okay, sounds good.
Okay, so you got your paper there all ready to go. So we're gonna plot a couple of points. All right. So the first point we're plotting is 5, 7 pi over 6. Now, if you look at the graph paper I provided, which is exactly the graph paper I've provided since the beginning, you notice that it is labeled in degrees. So having that is probably not a good thing, because that's a radian measure, and your graph paper is in degrees. So let's change that to degrees. How many degrees is 7 pi over 6?
7 times 180 divided by 6.
Yep, so we do 180 divided by 6, which is 30, times 7 is 210. Now, since you're going to have a calculator, if you want to do 7 times 180 divided by 6, that's fine. Without a calculator, I wouldn't do that, but with a calculator, you can. And either way, you get 210 degrees. 210 degrees is actually labeled on your grid. So you get on that line, the 210 line, and count out from the center 1, 2, 3, 4, 5 circles. Go out 5 circles from the center, from the pole, from the origin. It's actually called the pole. From here, count out 5 circles on the 210 line. Easy. Now the next one is -3, 270. Now we have a problem. You can't go on the -3rd circle. That doesn't make any sense. So we know we have to be on the 3rd circle. But the negative tells me I want to be at the opposite place. So if the original is straight down, then the opposite will be 90 degrees straight up. How did we say we were going to find that new angle always?
Subtract 180.
Add or subtract 180, right? Whichever works in this problem. In this case, subtracting 180. Because if you added 180, you'd be too big, right? So we're going to subtract 180 this time. And we're going to plot that on the 90 line, 1, 2, 3 circles up. So there is point B. Okay, remember when we count from the center out. Count from the center out. Okay, and now we're going to graph r equals 2 minus 3 cosine. Now Now, the good news is, back in the day, you had to do this by hand by plotting points. You don't have to do that because you've got a graphing calculator. So we're going to go to our calculator, and I suggested last time that while it isn't an absolute 100% guarantee, if you just kind of leave your calculator set up the way these examples are done, it's probably going to be, if it's not exactly okay, it's very close to being okay. All right? So first thing, we have to be in polar mode and in degrees. The only reason I say we have to be in degrees is because that's what our graph paper is. So we're in polar mode and we're in degrees. Okay? Now, I'm going to go to my window. And what should theta min and max be? 0 and 360. What should theta step be? Talked about it yesterday. 5. And then what about x's and y's? You got to have an x min, a y min, the x max, and y max. What might we do with that? 10 and negative 10 would be, or negative 10 and 10 would be fine choices. There are many other choices, but that's a good starting point. Negative 10 and 10 for the x's, and negative 10 and 10 for the y's. Okay, John and Janae, are you guys feeling okay? Okay, well, please sit up. Let's not nap somebody there. When she's asleep, wake her up. Let's wake up. Pay attention. All right, so once I get this all set up, I'm going to go ahead and type in my equation. So y equals, and I type in my equation, 2 minus 3 cosine theta. Remember, theta is your x button, your variable button, and then press graph.
It's a line of beam.
Now, what you should see on your calculator is something that looks like 1, 2, 3, goes out 5. All right, so it's something that looks like, I'm such a bad artist. Something that looks like that. You see something that looks sort of like that?
Yep.
Now, as I reminded you yesterday, when you transfer it from the calculator to the graph, it has to be the right size. So you can see on your figure, if you look at it, you can see, here's the pole. Can you see 1, 2, 3, 4, 5 is where it ends here? So when you graph it, that's how big you have to graph it. If it was only 4, you would go out to 4. So yes, if you have the right shape, you're going to get credit. But if you don't have the right size, you're not going to get full credit, okay? It does not have to be perfectly exactly drawn, but it has to be the right size. Okay? All right. Awesome. Number 2 is done. So you can see how short this is. So there isn't a